Swayam Prabha. Digital India. Educated India.
Hello, I welcome you all in this course on refrigeration and air conditioning, and today we will discuss different kind of AC systems. Say air conditioning has variety of applications starting from half ton of refrigeration or 0.1 of 1 ton of refrigeration to thousands tons of refrigeration. So for variety, when there is a variety in application, same type of system cannot be used everywhere. You cannot use same type of system for 0.1 TR and 1000 TR. So there are different systems for different type of applications. Number two, technology is also different. I mean, nowadays there is a lot of stress on energy efficient system. So over the years in air conditioning industry also the industry has evolved energy efficient system, because the saving in energy is directly related with the saving in the running cost of the system. So we will start with the small units of air conditioning system, that is a unitary system. So unitary air conditioning system means it is a self-contained unit or a split unit. It comes in the form of mass manufacturing from the industries, and these units, for example, window air condition. Window air condition is a self-contained unit. It is a box, and this box is fixed in any of the wall of the room. This box has all the arrangement, I mean all compressor is hermetically sealed compressor. In hermetically sealed compressor, the compressor and the motor are housed in a single unit. In a hermetically sealed compressor, the motor and compressor are housed in a single unit, and the wire connected to the motors they only come out of the body of the compressor, and the cooling of the motor coil is done with the help of refrigerant. So this hermetically sealed compressor is used in unitary systems, and they have evaporator and they have condensers. For the movement of air, a fan is provided, and a motor is provided. In fact, it has two fans. One is pushing window in this side, one is pushing in this side, that is condenser side. Here they are condenser coils, here they are evaporator coils and both the fans are mounted on the same motor. This unitary system can be fixed in any of the wall of the room. Now precaution has to be taken that a proper slope of the unit has to be maintained. A slight slope, backward slope has to be given, which is normally neglected by installation, because in this evaporator coil the condensation of refrigerant will take place. If backward slope is not given, then the water will start draining on the wall of the room. This you must have witnessed in many of the applications. So in this type of system, a slight backward slope is given, and the temperature of air which is at the grill is approximately 13 to 14 degrees centigrade. I mean, at this temperature air is supplied to the occupancy, and occupancy temperature, as I told you earlier, it is approximately, it has to be maintained around 25 degrees centigrade temperature and 50% RH, 50% relative humidity. Now another type of unit in a unitary system is a split type of system. Now split, here there is a split between high pressure side and the low pressure side. In a split system, in fact, there are two units. So, one unit is splitted in two units. In this unit, there is only expansion device and coil, evaporator coil, and there is a fan also which blows air over evaporator coil. This is inside unit. This is room wall, and outside this unit is connected with the outside unit, and outside unit has compressor and condenser, and it has got a separate fan. A separate fan is for outside unit and separate fan for inside unit. Now the vapor from evaporator, the cycle remains same. The vapor from evaporator goes to the compressor, from compressor to condenser, and condenser to expansion device, and from expansion device to the evaporator. Now this unit is a sort of silent type of unit, because compressor is outside. Major source of noise in any air conditioning system is compressor. So compressor is housed outside the building, and inside the building there is only evaporator and a fan. So noise level is low in this type of system. Second thing is, precaution has to be taken. The distance between these two must not be very large, should not be any case more than 20 meters. If this distance is large, definitely for the flow of fluid inside the pipe, the pressure drop will take place, and that will affect the performance of the system. Now these type of systems are suitable. For example, window type of air conditioning system is suitable up to say 3 tons of refrigeration. Now these type of split type of system we can go for higher capacity, but suppose I want to have 50 tons of refrigeration. 50 tons of refrigeration, none of these units will work. Single unit will work. If you provide multiple unit, that is another case, but single unit will not work for 50 tons of refrigeration. Now for such type of load, 100 tons, 50 tons or 100 tons, central system is used. Now unitary system, a package type of unit is also used. Package type of unit, I mean, it is a larger size of window AC, where everything is put in a one package and it is placed at the rooftop. It is a direct expansion type of system. Direct expansion time is after the expansion in the expansion wall, that is 1, 2, 3 and 4. So in this unit, after expansion in the wall, the refrigerant goes to the evaporator and the air comes directly in contact with the evaporator. This is known as direct expansion type of units. There is no secondary refrigerant like chilled water or brine, and this unit is placed at the rooftop, and air is supplied to a room or a set of rooms through ducts, and this type of unit is known as a package type of unit. Now central system, centrally AC system, there is a compressor house mainly in the basement of the building. There are two type of systems, where is direct expansion type of system and chilled water type of system. In direct expansion system, it is same. The air which takes heat from the room goes to the evaporator coil, gives heat to the refrigerant, and it comes back. And in chilled water type of air conditioning system, the chilled water is produced in the evaporator coil. In a separate tank, the chilled water is produced, and this chilled water is circulated throughout the building through a pump. The benefit of chilled water system is, if you look at the heat carrying capacity of air and water, suppose as you know that Q is equal to m Cp delta T. Suppose 1 kilowatt of heat has to be carried away by air. For we have to find the mass of the air. So, mass of the air, Cp for air is 1.005 and delta T, let us say delta T is 25 degrees and 20 degrees centigrade, right. We can find the mass flow rate of the air, and in the similar case, suppose 1000 has to be carried away by the water, 4.18 into let us say 20 again, because specific heat of water is approximately 4 times the specific heat of air. So, mass of the water is automatically reduced by 4 times. Suppose here we need, suppose in a case we need 1 kg of water, 1 kg per minute of water, then air will need only 4 kg per minute. That is one thing. Second thing is, if you look at the density of air is 1.2 at normal temperature pressure, that is 1.2, not normal temperature, STP. I mean at 25 degrees centigrade, it is 1.2 kg per meter cube, density of air. Now, density of water is approximately 1000 kg per meter cube. So, it is 7 or 800 times. So, now you can imagine the amount of water is required to carry the heat, which is equivalent to the heat carried away by the vapor. So, for very large systems, instead of using air, water is used for as a medium of heat transfer, and water works as a secondary refrigerant. It takes heat from the room and then heat is discharged to the evaporator. Now, in some of the cases, mixing of these two is done. That is also there. The mixing, I mean, part of the system is running with the air, cold air, and part of the system is working with cold water. Now, if you look at a typical fan coil unit which is used in a system, in a chilled water type of system. So, this is a unit and it has, first of all, a filter is provided. Filter are must in the circuit, otherwise the contaminated air will enter the room, and this side there is a passage for fresh air, and this side there is a damper for room air, and this side is for fresh air. Now, fresh air enters from this side. Room air means return air which is coming from the room, it will enter from this side. They will get mixed here, and there is a coil arrangement here, chilled water coils arrangement here. Air is blown over these coils with the help of a fan or a blower, and then it is supplied to the room. So, this is a typical arrangement for fan coil unit. Which is used in air conditioning systems. Now, in addition to the fan coil units, this is all air system, I have already explained, all water system, the fan coil unit will be used. Now, third type of system is air water system. So, in this system we take benefit of both the systems, air systems and water systems, and the cooling in the system is done with the help of air and water. Now, in this type of system, we take induced air from the room. So, induced air from the room, that is return air from the room, it enters from this side and there is a fan coil arrangement. So, this air, when it comes into the contact of chilled water circulated in this coil, it gives heat to the chilled water. Now, fresh air from AHU, the air from air handling unit comes from this side, and there are dampers here. So, dampers helps in controlling the mixture, how much fresh air shall be mixed with the return air with the room of the room. And because these air, they pass through a nozzle, the nozzle is this extension of this, there are nozzles, and after mixing it is supplied here, right. This mixed air is a mixture of the fresh air coming from the AHU and the air coming from the room. So, likewise there can be many arrangements in central system. Now, third one is constant air volume system. Now, these unitary systems like window AC, split AC, most of the system or earlier system, they were constant air volume systems. Constant air volume system means constant volume of air is discharged in the room, right. So, the flow in the room is coming is constant. If you look at the data sheet of any split AC or a window type AC, the flow rate is fixed. Flow rate is fixed, maybe 300 CFM, just 300 CFM or 500 CFM, whatever the flow rate is fixed. So, that is why they are called constant volume system. The constant volume system can be a single zone system. The single zone can be a single room or multiple room or even a floor. A floor can also be a single zone. Now, in different zones, different environmental conditions can be maintained. That is why a big building, normally in big buildings, zoning is done, right. And for each zone normally for all air system, for each zone there is a separate expansion device. Now, this is a terminal reheat system. This is very interesting. Suppose in a particular zone, we do not need very low temperatures. For example, in one room, the temperature requirement is 21 degrees centigrade. In another room, the temperature requirement is 26 degrees centigrade. So, in a terminal reheat system, at the point of supply of air, heating of air takes place. So, cold air may be entering from this side at 21 degrees centigrade, but zone where 26 degrees centigrade temperature is required, the heating of air is done. Heating of air is done and there is a heating coil. We can do the electrical heating can be done, or heating with a steam, heating with hot water, any mode of heating can be used, and this temperature is increased to 26 degrees centigrade. Now, terminal heating system is not a very efficient system. Definitely once on the one side we are cooling the outside air which is available at 40 degrees centigrade to 21 degrees centigrade, and again we are heating it to 26 degrees centigrade. So, this system is not very energy efficient system, but it is very flexible and easy to control, because we have to simply use the heating. Suppose electrical heating system is there, so fine control can be done in such type of system. So, in terminal reheat type of system, the heating of air takes place at the supply terminal. Now, dual duct system. The dual duct systems are normally very popular in the industries where air supply and return both ducts are provided. One is supply duct, another is return duct. The velocity of air remains comparatively higher in these type of ducts. They are smaller in size, and normally when the velocity is high, pressure loss is also high in such type of ducts, and these ducts are also helpful. This type of arrangement, dual duct arrangement, is also useful in making the system more efficient. But this type of system, it may not be efficient, but it is, I mean, the terminal reheat type of system is, I mean, it is very flexible and workable system. So, dual duct system, there are two ducts. One is supply ducts, the air supply at a very high velocity, and then there is a return air. For example, suppose a worker in an industry is standing before a furnace. Furnace is at very high temperature. So, we cannot cool the entire environment. So what is being done? Air is blown over the body of the worker and from the supply duct, and it takes the U-turn and goes through the return duct and it is taken away. So that area gets, in fact the human occupant of that area gets the comfort cooling by the air, but the entire area is not cooled. So dual duct system has many advantages like this. Multi-zoning in a building, definitely some part is 26 degrees required, some part 21 degrees required, or different air conditions are required at the condition of air is required in different part of the building. So multi-zoning is done and each zone is provided a separate expansion device to attain the state of the air. Now the fourth is variable air volume system, VAV system. Variable air volume system means, so it is a sort of on-off type of system. You must have observed in window AC or split AC, it does not run continuously. It switches on and switches off. So if thermostat is fixed, let us say at 25 degrees centigrade, so when the temperature is 26 degrees centigrade, 26 degrees centigrade, it will switch on. I mean, it depends upon the setting. And when temperature reaches 24 degrees centigrade, it will switch off. Flow rate will remain same. So when 24 degrees centigrade air is reached, temperature of air is reached, the system will switch off. Slowly the temperature will start rising. When it goes to 26 degrees centigrade, system will again switch on. Now in air conditioning motor, the starting current is very high. Starting current is approximately 3 to 4 times the normal current. That is why 15 ampere fitting is done for window type of AC. Window type of AC, suppose 1 kilowatt motor. 1 kilowatt means 1000 watts, 230 volts, or let us say 250 volts. So it is 4 ampere, right? And 4 ampere, because starting current is high, 4 ampere. Normal house domestic electrical wiring is 5 ampere wiring, right? But we don't use normal wiring. It's dedicated wiring is provided for window type of AC, because starting current is 12 or 13 ampere. It is 3 times. So starting current is high, that is why 15 ampere wiring is provided for window type of AC. So we are talking about the variable air volume system, where volume of the air changes, right? And if when the temperature inside the space reaches the required temperature and we no longer require cold air, the dampers starts closing, and the static pressure in the duct it increases. When there is a shoot in the static pressure in the duct, it gives signal to the air handling unit and the supply of air in the room is reduced. So variable air volume system is an energy efficient system. Now air water induction system, fan coil unit with separate primary air, I have already explained you this type of system. Now this one VRF system, this is important, I will take up this one, VRF system. Now VRF system is variable refrigerant flow system. So instead of controlling air flow in the system, refrigerant flow in the system is controlled. Instead of suppose in a cycle, as you know, the pH diagram, so the heat taken away by the refrigerant depends upon H1 minus H4 multiplied by mass flow rate. Now if I vary this mass flow rate as per the load on the coil, I shall not have to make any other arrangement. So this type of arrangement where mass flow rate is varied according to the load on the coil is known as variable refrigerant flow system. So it has many applications: offices, school, college, hospital, home, retail store, multi tenant residential building, restaurants, hotels, data center. Now in variable refrigerant flow system, scroll compressors are used. Scroll compressors are but nothing but they are spirals. There is one spiral, and in the scroll system there is compressor, there is another spiral, right? And one spiral revolves, not rotate, revolves around another spiral. So when they revolves around another spiral, the refrigerant, cold refrigerant entering from this side from the evaporator, it get compressed and it emerges here from at higher pressure. So this compressor is used for VRF system. Now in this compressor, if I change the frequency of this revolution of one is fixed spiral, suppose black one is a fixed spiral and this is the spiral which does the revolution around the fixed spiral. So if I control the frequency of this moving spiral, I can control the mass flow rate also. So this type of technology is known as inverter technology, where with the help of frequency of moving spiral the refrigerant flow is controlled. Now another type of technology in this VRF system is digital scroll type of technology, where because it has certain height also, the spiral has certain depth also, and that is, and they are engaged with each other to a certain depth. One is fixed and another. If I change this overlapping, okay, if I change the distance between these two spirals, one spiral is fixed inside the another spiral. If I change the suppose this is fixed spiral, this is moving spiral like this. So if I change the overlapping of these two spirals, that can also be controlled for, that can also be used for controlling the mass flow rate through the system. So nowadays VRF technology, this is the latest technology, it is emerging fast, and at the part load of, I mean up to 10% part load, I mean that is very high, 10% of the part load, it gives the efficiency is maintained. So if in those applications like hotels where, I mean we do not know the load in the system, this type of technology is very helpful. There is another type of cooling system which is totally environmentally safe, that is steam jet cooling system. In steam jet cooling system, water is used as a refrigerant and chilled water is circulated in the evaporator. Now the water cooling is done in a flash chamber, and in flash chamber the water is evaporated. In order to evaporate water, vacuum has to be created inside a flash chamber, and for creating vacuum inside the flash chamber, a steam ejector is used. So from a boiler, steam is supplied to the steam ejector. Inside the ejector there is a nozzle which imparts very high velocity to the steam, and this very high velocity of steam creates low pressure just in the vicinity of the neck of the nozzle, and this neck of the nozzle is connected to the flash chamber. So low pressure, very low pressure is created inside the flash chamber and the water is evaporated. For the evaporation of water, heat is taken from the pool of water present inside the flash chamber, and that causes cooling of water inside the water present inside the flash chamber. This water is circulated in the evaporator coil with the help of a pump, and cooling water after taking heat inside an evaporator, it is expanded in the expansion wall and it is sent back to the flash chamber. Now there are several advantages of this system. First of all, it is flexible in operation, it has no moving part and it is vibrations free. It can be easily installed outdoors. Weight of the system per ton of refrigerating capacity is less. System is reliable and maintenance cost is less. and this system does not have any leakage hazard which may happen in the case of other refrigerants. So, this is a special type of system which is absolutely environment safe, but the only issue with this system is it cannot be used for the temperature where the temperature requirement is less than 0 degree centigrade. So, this is all for today, and in the next lecture we will start with the human physiology.